Hey guys, welcome. As this is example 0, it means that we're going to talk about first order linear differential equations in the most general case. So in this video, we're going to derive a formula that's going to allow us to solve all first order differential equations written in this form. And of course, in subsequent videos, I'm going to give you example 1, 2, and 3, where I'll go through specific problems. Those specific problems will use the formula we derive here in example 0, yeah? Cool. All right, let's get started. So to start, what we're going to do is take our given equation here and notice that our equation is given with the coefficient of y prime being 1. And so your equation needs to also say that. Otherwise, divide on both sides of the equation by whatever is multiplying y prime if it's not 1. Yeah? Okay, cool. Anyway, if it's 1, then proceed in the following fashion, which is take this given equation and multiply it on both sides by a function q of x. We're going to require that q of x have a special property in a second. But to start, let's just multiply by q of x. So that'd mean that multiplying both sides of this equation by q of x, we can write q of x times y prime plus q of x times p of x times y is equal to q of x times g of x. Yeah? And here's a special property that we're going to assume q of x has. And that is that q of x times p of x be equal to q prime of x. So the integrating factor q of x is such that when we multiply it by p of x, q of x times p of x equals q prime. You're going to see that this is going to suit us really well a little bit later. Well, immediately it suits us because then that'd mean that we can write what's in front of y as q prime, right? And look at what that'll do. So if we can write q prime of x here, never mind that this guy's written kind of far apart, but this is what we'll have, right? But looking at this sum here, this sum is clearly q of x times y prime. That is, this here is the use of the product rule on the derivative of that, right? So this here equals that. Fine. So then we write this equals q of x times g of x. And then it should be clear what we're going to do next. We're going to integrate on both sides, all right? And when we integrate on both sides, well, maybe we don't know what the integral on the right side is, but the integral on the left side, we know for sure. It's going to be the following, right? The integral on the left is going to be y times q of x plus some constant. And on the right side, let's write integral q of x of x. And dx, of course, but yeah, I didn't have space here, but you figured, right? Okay. All right, anyway, we're going to move forward from this, right? We're going to move forward from this. Okay, cool. Now, let's move this, a nice little spin to it. Let's move this here. Okay. And ultimately, we're trying to solve for y. So what we're going to do next is take this equation and subtract c from both sides. But even if I subtract c from both sides, it's still a constant, right? So I have, well, ahead of myself, y times q of x is equal to integral q of x times g of x. And then plus, let's say the constant is now like a, yeah, plus a. So negative c is a. Fine. And it's clear what I'm going to do next, or what I want to do next. And that is divide everywhere by q of x. That is divide on both sides by q of x. And if I did, then it looks like I've gotten our solution y. And I do. I do have it. Yeah? Okay. And this is the solution. So we have that y equals, well, I'm going to write this in front of the integral right there. And I'm going to write it as follows, which is q of x to the negative 1. And then I have that times integral, and then it's q of x times g of x. And then I should have a plus a here, because don't forget that I should have a parenthesis that corresponds to the one on the left. Well, okay, here, how about that? That's better. And don't forget that this is multiplying a as well, right? That's why that parenthesis was important. Okay, cool. So for now, it looks like this is as like nice as we can write our solution. I'll return to it, and we're gonna do more to it. And we're gonna do more to it precisely because of what we assumed about. We're gonna be able to do more to it precisely because of what we assumed about q of x. Remember, we had assumed that q of x has this property, right? Okay, cool. So look at what that leads to. If q of x has that property, then on my next step, I could divide on both sides by q of x here and here, right? And write that p of x is equal to q prime of x divided by q of x. And so then that would mean that the integral of p of x dx, let's say, is f of x. And the formula that I'm going to give you at the end of this video, the formula that we're going to be using in examples 1, 2, and 3, we're saying that the integral of p of x is f of x. You'll need to calculate f of x every time. And maybe in a different book or in a different reference material, it's called some other function h of x, but doesn't matter. You'll still need to figure out whatever is the integral of the function multiplying the y term and your equation. And whatever that is here, we're saying we're going to call it f of x. Well, if that's the case, then notice that as soon as I integrate both sides of this, first on the left side, I'm going to have to write f of x from what we just said. And on the right side, I'm going to have to write, well, it's f of x plus c, but keep in mind the constant. But, well, f of x is this integral, the integral of that plus a constant. Yeah, okay, so that's already implicit there. Anyway, that there's a constant, but we don't need to worry about the constant because there's a constant from the right side and we need to combine them into one. Now, let's actually write the constant on the left side, the constant that we'd have to get from there, even if we can't agree on whether or not we should write f of x with a constant. You get what I'm saying. Anyway, let me say that the constant from the right side, we move to the left and call it k. Well, clearly the integral here, other than the constant, is the natural log of q of x, right? Okay, so we have the natural log of q of x. And then the constant we've moved to the left side. Now what we're going to do next is to get to q of x, we're going to raise both sides with a base e, right? And so on the right side, we get q of x. And I need to erase, so let's erase here. So on the right side, clearly I get q of x. So let's note that. On the left side, however, I get e to the f of x and then e to the times e to the k by exponent rules. Let's say that e to the k is equal to some constant b, let's say, yeah? So then I could write this left side is b times e to the f of x. So q of x equals b, some constant b, times e to the f of x. Yeah, we're almost there. Okay, cool. So we actually already have found the solution y. It's just that we want to write it nicer. So y is right up there. And in case you forgot where, I mean right up here, right? That's y. Okay, so now let's rewrite our solution y and clean it up. So we're going to say y is equal to, and it's going to be q of x to the negative 1. So that means b to the negative 1 and then e to the negative f of x. B to the negative 1 I'm just going to write as 1 over b. So we have 1 over b and then times e to the negative f of x. And then we have, and that's q to the negative 1, right? And then we have that times, and then it's going to be times the integral of q of x is, again, b e to the f of x, and if you don't know where I'm looking right there, and then times g of x. G of x is given from the beginning, so nothing to find there. G of x, and then dx, and then we have plus a here, right? Okay, cool. So we're almost at the finish line. Now look here, guys. If I write a over b here, then I could get rid of this b right here, right? And that's pretty straightforward algebra, and write a b where I have a 1, right? I should be able to do that. So basically I'm saying I factored out a b. And of course it's silly to write b over b. We're going to get rid of that. Now the only thing that we're going to do is we're going to say that a over b is some other constant lambda, and here is our solution as it's written in every book. E to the negative f of x times integral, and then it's e to the f of x times g of x dx plus lambda. And key thing to note is that, yeah, lambda is also being multiplied by this guy. Yeah, cool. So here's the all important formula. And the examples, we start with this, and that's it. And we just simplify the integral and all that good stuff, because we know that f of x is the integral of this, and then we have g of x. So given an initial condition, we can determine lambda, but otherwise, you know, this is ready-made if you have p of x and g of x to start, right? In other words, we wouldn't reinvent the wheel. We just start with this formula and the examples, as you will see in examples 1, 2, and 3. All right, cool. I hope you enjoyed this, and keep watching.